Hello, dear aspirant. This is Dr. Sourav Char's classes. Our contact number is 9836793076. Again, I am repeating our contact number, which is 9836793076. And our email ID is classes@gmail.com. So, if you have a mathematical query, doubt, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp. Also, rather, you can drop an email to our email ID. Then our team can arrange a clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay, like CSIR NET, NVHM GATE, etc. So please feel free to contact if you need any help on us. Okay. So now we are going to solve a problem which is appeared in the CSIR NET question paper and the question June question paper, and the question is telling us that let A, where our A is belonging, A is running from R to the power M to R to the power N, Rm to Rn, be a non-zero real linear transformations. Okay, a non-zero linear transformation. Which of the following statements is true? The option A is telling us that if A is 1 to 1 but not on to, then M greater than N. Option 2 is telling us that if A is on to but not 1 to 1, then M less than M. Option 3 is telling us that if A is bijective, then M equals to N. And option 4 is telling us that if A is 1 to 1, then M equals to N. Okay, so let us see what can we do. So let us analyze each statement one by one. Okay. Now we have to first give the definitions of 1 to 1 and 1 1 and on to linear operator here. So now what can we do? Okay. Now what is a 1 to 1? That means injective linear operator. So a linear transformation, let us call A, which is from Rm to Rn, is injective if our Ax is equals to Ay, implies our x equals to y. Now this means the null space of A is trivial. That means our nullity of A is equals to B. Now the surjectivity, that means the onto operator. So A is surjective if for every B belongs to R to the power n, we can say that there exists x belongs to R to the power n such that our Ax equals to B. This means the column space of A is all of rank R to the power n. That means our column space of A is equals to this, and that can be, then we can say that our rank of A is equals to 2. Okay, so now we have to use another very important theorem to solve this question. Let me shift the screen first. Now the important theorem, which is rank nullity theorem. In this, we can see that the rank of A plus the nullity of A, the nullity we can write as nullity of A is equals to what? That should be equals to the number of columns, so which is M here. So now, where our rank of A is the dimension of the column space and nullity of A is the dimension of the null space, now we are going to analyze the statements. Okay. So the statement A was telling us that if A is 1 1 but not onto, then our M is greater than 2. Let us think our A is 1 to 1. That means our nullity of A is 0. Then our rank of A will be what? That should be M. So now, if our A is not 1, then our rank of A is less than N. So our if our nullity is if our A is not on, so then we can have that our nullity of A that should be less than N. So from this we can say that our M should be then less than N. So this statement claims M greater than N, which is called the correct conclusion should be our M less than equals to N. So now, now we have to evaluate the second statement, which is telling us that if our A is on 2 but not 1, then our A is less than 4. So our A is on 2. So then what can we say? As our A is on 2, so from this we can say that our rank of A is equals to N. Okay. So now A is not 1. So the nullity of A is greater than 0. So rank of A is less than M. Thus our N less than M. So we are getting M greater than N. And this statement claims M less than N, which is false. So the correct conclusion will be M greater than N. Okay. So now if A is bijective, then M equals to N is the hard statement. So now A is bijective, then the nullity of A is equals to 0 and the rank of A is equals to N and our M is equals to N. So we can, by the rank nullity theorem, we can easily say that our M is equals to N because the rank plus nullity is equals to the thing which is M here, and we can say that the rank of N A is N and the nullity of A is 0. So the by the rank nullity theorem we can say that our A is equals to N for A is, if our A is bijective, then it's okay. So now if our A is 1, then M equals to N is the fourth statement, which is false because as our A is 1 to 1, nullity of A is equals to 0. So the rank of A will be then what? So the rank of A will be M. So then, but we know that the rank of A is less than equals to the minimum of M comma N. So this statement claims M equals to N, which is false. Our M should be, M can be greater than M. Our N can be greater than M. No. So A can be 1 to 1 with M less than N. That means like a embedding. Like embedding, if we take R to the power M into Rn, where our M is less than N. So by these conditions, we can say that the only true statement will be our statement 3, which is telling us that if A is bijective, then our thing, that means the M is equals to N. Okay. So the correct answer of this question will be our option 3. Okay, hope you understood, guys. Again, I am telling that if you have any other mathematical queries, doubts, or anything, so please feel free to contact on this number. That means you can call on this number or WhatsApp also. Rather, you can drop an email to our email ID. Then our team can arrange a clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations. Okay. Hope you understood, guys. Thank you.